Hello, today we're looking at 8.2, solving systems of equations. We've already done a little bit of this in class together, but we're going to get a formal lesson on it today and finish it up. So we'll start with a quick review, a warm-up of 8.1 here. So for the linear function defined by this equation, determine the slope. Well, the slope is minus 2, or minus 2 over 1 if you like it in rise over run form. The y-intercept is minus 1. Draw the graph over here, so the y-intercept is right here. Slope is minus 2. That means instead of right and up, it goes right and down. So we go rise is minus 2, over run is 1. So you go 2 down, 1 over, 2 down, 1 over. Okay, and then it would continue in the other direction like that. Alright, for the quadratic function defined by this equation, determine coordinates of the vertex, -3, +4. So that is -1, 2, 3, 1, 2, 3, +4 right there. I'm going to use a different color here. Okay. Draw my line in. Okay. Pretty poor, but you get the message. Alright. So the quadratic is right here, the concavity of the graph. A is negative, so this is going to open down. The width of the graph is normal, which gives us a lot of the information we need because this is just -1. So 1 means normal width. So we can make jumps of 1a, 3a, 5a, and so on. A is just 1, so the jumps are going to be 1, 3, and 5. So we go 1 over, 1 down. Already found a solution. 1 the other way and 1 down. Now from here we go 1 over and 3 down. And 1 over and 1, 2, 3 more down. Then we go 1 over and 1, 2, 3, 4, 5 down. We go 1 over and 1, 2, 3, 4, 5 down. And we'll find that we don't get any more overlaps. This is the only one because our line happens to be tangent to our parabola, our quadratic here. So there's just going to be the one solution right there, and it happens at x is -2 and y is 3. So we have this point, -2 and 3. This is a point that exists on both graphs. So if you plug -2 into here, you'll get +3. And if you plug -2 into here, you'll get +3. Okay, so there's that one. It's done. Here we have two quadratics. We can go quickly with this one again. The vertex is a +2 and +4. 2 and 4 right there. It opens down and it's normal width. Okay, so we go 1 and 1, 1 and 1, then we go 1 and 3, 1 and 3, we go 1 and 5, which is down here, and then of course symmetry would put us over there. So there's your first one. Take a look at the next one. +3, -1. So 1, 2, 3, and 1 down. That's your vertex. This one opens up, and it has normal width. So we go 1 over, 1 up, 1 over, 1 up. So you can see there's already a point of overlap. 1 over, 3 up, second point of overlap, 1 over, 3 up. And then we don't really need to continue drawing the rest of it, but it would be there. So we've got our 2 points of overlap at 1 and 3, and at 4 and 0. There you go. Alright, so solving a system of linear equations algebraically, linear quadratic, sorry, because we have one linear, one quadratic. So we want to solve this system. Now, all that means is we basically set them equal to each other, because that will allow us to find out when or what values, at what values on the graph they overlap. So I'm going to solve each of these for y. So the first one, I'm going to move y over to the other side here, make it positive, and I'm going to move 10 over to the other side there. So it ends up being y equals 5x minus 10. Now the quadratic, I'm going to get y alone by moving it over here, the 2y, and then dividing everything by 2. So y equals x squared plus x, and each of these will be divided by positive 2. There you go. So we want to find out when they're equal to each other. So since they're both equal to y, we want to find out when those y's are equal. So we set 5x minus 10 equal to x squared plus x, both over 2. Okay, now let's get this in a more usable form. Multiply everything by 2. So on the left side we get 10x minus 20, and on the right side we get x squared plus x. That's more like it. Alright. Group everything to one side and leave the other side as 0. So keep your x squared positive. X squared plus x minus 10x, because we're moving this over to the other side here, and then plus 20 because we're moving that over to the other side as well, and that equals 0. Now we can begin to solve for the zeros of this system. So x squared minus 9x plus 20 equals 0. The factors of 20 are 20 and 1. We have a negative sum and a positive difference, or a positive product, sorry. So both your factors are going to have to be negative, whichever ones you choose. We have negative 2 and negative 10. We have negative 4 and negative 5. Okay. Choose the two that add up to negative 9, and it's these ones right there. So we get x minus 4 times x minus 5 equals 0. And that shows us that there will be two places where these two graphs overlap. And they will have x values at 4 and at 5. Okay, and then you can plug 4 back in, do it into your easier equation right here, or this version of it. Plug 4 into that, solve for the y value, so we get y equals 5 times 4 minus 10, so that's 20 minus 10, and the answer is 10. You'd get the exact same thing if you plugged it into this one, because that's where they were equal. They have the same coordinate at that point. So we have the point 4 and 10. And then do the same thing with 5. So you plug 5 in and you get 5 times 5 minus 10. 5 times 5 is 25, minus 10 is 15. Okay, and you have the point 5 and 15. Here's your turn. Go ahead and try to solve this using whichever method you want, like the method that I just showed you. So basically solve for y, set them equal to each other, and give it a go. Answer will be here as always. There you go. Okay, quadratic equations. So a system of two quadratics. So again, set them equal to each other and solve. We want to know where they overlap, so that is where their coordinates would be equal. So where 4x squared plus 8x plus 4 is equal to 3x squared minus 2x minus 5. Okay, group everything to one side. So subtract those, add those, and add that, and we get 4x squared minus 3x squared is x squared. 8x plus 2x is 10x. 4 plus 5 is 9. And then 0 is left on the right. We can solve this thing. Factors of 9 are 9 and 1. So there you go. Those add up to positive 10. That's the only thing we could have done because 9 is prime. So x equals minus 9 and x equals minus 1. And then you can solve for the y values that correspond with those. I'll do one for you and let you do the other one. I'll do the 9 since it's a little harder. And I'll show you that it works for both of them. So the first one we go 4 times 9 squared plus 8 times 9 plus 4. So that's 4 times 81, which I believe is 324. Okay, so 324 plus 72 plus 4. So 396 plus 4 is exactly 400. That's nice. So then our point is minus 9 and 400. I'm going to test it with the other one, and then I want you to find out which y value corresponds with an x value of minus 1. So let's test this one here. 3 times x squared. How are these possibly going to be the same? 9. Oh, it's minus 9. Oh, doll screwed up. Minus 9. Minus 9. Okay. Okay, this should be minus 74. Which means, sorry, minus 72. Which means we get a point of 248. Okay, that makes more sense. So this is 248 when we plug it into the top quadratic. See what happens here then. Times minus 9 minus 5. This is 3 times 81, which is 243, I think. 243 minus 2 times minus 9 is plus 18 minus 5. So this is plus 13 right here. So 243 plus 13 is 256. Alright, I see what went wrong here. This right here. Third time's a charm, I hope. 324 plus 4 is 328. I subtracted 4 last time. So 328 minus 72 is 256. Okay. Did it in a roundabout way, but shown that when we solve the two equations together, the zeros of the function are obviously the points where they overlap, and that means we'll have the exact same coordinate, x and y coordinate, at those points for either function. So I'll leave that one to you. Hopefully you don't make as much of a mockery of it as I just did. Okay, so let's continue here. So here's a warm-up. Set the two equations equal to each other. 2x squared plus 3x minus 3 equals x squared plus x. Subtract these both to the other side. So we set the whole thing equal to 0, and we get 2x squared minus x squared is x squared. 3x minus x is plus 2x minus 3. So what two things multiply to give you minus 3 that add up to positive 2? The answers you'll find are minus 3 and 1. So we go, or sorry, plus 3 and minus 1 actually. So you go x plus 3 times x minus 1 equals 0. X equals minus 3, x equals 1. But we're not done yet. We need to find the y values that correspond with these x values. So plug it in to either equation. Doesn't matter which one, so let's use the easier one. So let's go negative 3 squared minus 3, which is 9, minus 3, which is 6. So then we have the point negative 3 and 6. Of course, we have to test x equals 1 as well. So we go 1 squared plus 1 equals 1 plus 1 equals 2. So our point is 1 and 2. And that just comes from plugging the values into this equation. Find you'd get the exact same thing if you plug them into the other one. So let's try with 1. 2 times 1 is 2. Plus 3 times 1 is 3. Minus 3. 3 minus 3 is 0. You end up with 2. Perfect. Okay, modeling a situation. Glenn loves to challenge himself with puzzles. Good for Glenn. He's got his little Rubik's Cube on there. He comes across a website that offers online interactive puzzles, but the puzzle makers present the following problem for entry to their site. So you like puzzles? We'll prove your worthiness by solving this conundrum. Determine two integers such that the sum of the smaller number and twice the larger number is 46. A lot of information in here. Also, when the square of the smaller number is decreased by 3 times the larger number, the result is 93. Yikes. Okay. Start by writing down what we know. Two integers. Let x equal smaller number. Okay. So, two integers. The sum, that means we're going to be adding something, of the smaller number, that's x, and twice the larger number is 46. Okay, so let y equal larger, that's a handwritten L, larger number. So twice the larger number would be 2y, and their sum is 46. So that's equation number 1. Also, when the square of the smaller number, so the square of the smaller number is x squared, is decreased by 3 times the larger. Decreased means you subtract 3 times the larger. The larger is y. 3 times the larger is 3y. The result is 93. Result is means equals, and it goes like that. Okay, so there you go. We have this system of equations. All right, and all we need to do then is solve these. So let's isolate y in each of them. First one, 2y equals 46 minus x. So y equals 46 minus x all over 2. The bottom one, 3y equals x squared minus 93. So y equals x squared minus 93 all over 3. Set these equal to each other. 46 minus x over 2 equals x squared minus 93 over 3. So let's multiply each side by 2 to get rid of this denominator, and then multiply each side by 3 to get rid of this denominator. So if we multiply each side by 2 and 3, we're multiplying each side by 6. But I guess, okay, let's just do them in separate steps. So we multiply this side by 2, and that just disappears. We multiply this side by 2, and we get something that looks like that. Multiply both sides by 3. This side, this one disappears, and this side we get something that looks like that. Okay. So 3 times 46 is 138. Gotta learn to trust myself, I guess. 138 minus 3x equals 2x squared, and 93 times 2 is 186. So minus 186 right there. Alright, put them all together on one side. 2x squared plus 3x. So we've added this 3x over to this side. We're going to subtract this 138 over to this side as well. So minus 186 minus 138 gives us negative 324 equals 0. Can't divide everything by 2 because your linear term here is not divisible by 2. So we have to solve this system as it is. You could go ahead and try to find the factors of 324, or you could just use a quadratic formula, which I'm going to do. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So we get negative 3. So that's b is 3, not 3x, just 3. We never include the x's in the quadratic formula because we're solving for x. So we don't want them in there. So negative b is negative 3 plus or minus square root. B squared is 3 squared, which is 9, minus 4ac. A is 2. C is minus 324. So we're going to get a large number in there. All over 2a, which is 2 times 2, which is 4. Alright. Negative 4 times 2 times negative 324. 4 times 324 equals times 2 equals 2592. So negative 3 plus or minus square root 9. And this was negative and this was negative, so that's going to be plus 2592 all over 4. Okay. Negative 3 plus or minus 2592 plus 9. Oops. Divided by 9 equals plus 9. 2601. Doesn't look like a perfect square because of the fact that there's a 1 at the end, but you never know because 9 times 9 is 81, so it has a 1 at the end. So let's see if we can find the square root of 2601. So in our handy Google, there you go. Square root of 2601 is 51. So it is a perfect square. and that'll be all over 4. So we get negative 3 plus or minus 51 all over 4. So there's two paths here, negative 3 plus 51 all over 4, and negative 3 minus 51 all over 4. So negative 3 plus 51 is positive 48. 48 divided by 4 is 12. So that's one of your x values. Negative 3 minus 51 is negative 54 divided by 4. 54 divided by 4, 13.5. So that's negative 13.5 will be your other x value. All right. And then, of course, we'd plug these back into one of the original equations to find the y value that corresponds with them. So here, if you want to take some formal notes on it, show you everything that we did in a more formal way here. Pause and look through the notes, catch up on them. There you go. So 13.5 wasn't an integer, which was specified in the question. It had to be an integer, so we have to discard it. 12 is an integer, so then we use 12, plug it back into the original, one of the original equations, and you find it. The other one is 17. So there you go. And we verify by proving that it actually works. And there's your access key based on what the problem is asking us to do. Here's your turn. Go ahead and give it a try. There's your answers. Here's another your turn. I can let you give it a try. Don't have the answers ready for this one, but if you have any questions about it, we can double check it tomorrow. Another one if you want to try it. Okay. Try them all if you're feeling ambitious. Otherwise, see what you can get through today. See you later.